Welcome back, everyone. In the last video, we set up our project so we could start coding. In this video, we're going to be getting the board class set up. We're going to be making it so we can store pieces in it, along with loading fen strings. We're also going to get its dependencies set up and render the board to the screen. All right, before we get started though, I'd just like to state a couple of things. One, everything I do is going to be put on GitHub, so if you don't feel like actually typing out the scripts, or you just want the final project, you can just copy it from there or download the whole thing, whatever you want. I would also like to state I've made a bunch of hardware changes. Like I have a different microphone. I don't have my normal keyboard, so it's going to be a little bit harder for me to type. And overall, my setup has been moved. I also got rid of my other monitor I was using for a previous run. This is also my first tutorial, and it's going to be a lot harder for me to dry run, so expect a lot more stuttering, spaces, etc. That being said, let's jump into it. Wait, pause, editor from the future, just made a discovery. Well, I made the discovery later in the video, but just discovered how big of an issue it was. You notice how I can right-click over here and click add, and you see these menus and stuff? Yeah, well, if I go over to how I had OBS configured previously, that is, you don't see any of that anymore. So, I'm adding a new class, and to prove it, I mean, on the off chance you really don't believe me, bam. Yeah. Bet I surprised you with that one. No, so, I apologize for that. So if you see me just randomly clicking on menus over here, that's because OBS was misconfigured. I fixed that way later in the video, but sorry, moving on. All right, so first things first, let's start adding our scripts. The first script we're going to add is our board class. Board. We're going to get rid of all these unnecessary usings. This is going to be a public class. We're going to get another script in here. This one is going to be a piece. It's not going to be a class, however. It's going to be a public struct. Gonna get rid of this pesky new line. All right, first things first, we're gonna build out our piece class. So originally I wanted it to be compacted into 1 byte. So in my previous spot, a piece actually was only represented with 5 bits of data, 3 of which were just unused as far as the byte was concerned. I didn't do anything with it. But I figured for this tutorial, that's unnecessary. You can figure out all the bit compression stuff. For now, we're just going to represent it with 3 variables and some extra methods and constructors. So what defines a piece? So first of all, its type. So we're going to have a public piece type. This will be its type, and it's going to be equal to piece type dot null. So that's going to be its default. It's also defined by its color. So black will be, or false will be black, true will be white. I don't know why I said that in the wrong order. But by default, this is going to be black. I thought Visual Studio wouldn't get this mad at me for having a non-existent thing up here. So we're just going to quickly define what a piece type is. This is an enum. Piece type. And the first thing is null. The second thing is pawn, knight, bishop, rook, queen, king. All right. Public bool color. Public bool has moved equals false. Actually, I wonder if we could just do that. Does that look better? I don't know if that looks better. I'll just keep it like this. All right. And then let's quickly get our constructor in here. Let's also make another constructor for being able to fill out, type, color, and has moved. So generate a new constructor. I clicked on this and I hit Alt Enter. So generate constructor. I want it to generate one for all of these. And I like things in Pascal case. So you can just quickly hit the right arrow to skip this. Or optionally the L key, but that might take you too far. All right. And I think that's all we need for the piece. Next, we're going to move on to our vector script. So this is going to be a public s byte or assigned byte. anywhere from negative 127 or 128 to positive 127, I believe. So this is going to be our x and our y. By default, these are actually both 0. We're still going to need our constructors, though. So public chess vector. We're just going to have an empty constructor along with a constructor that'll actually take in. So I'm going to make these. Oh, actually, for the tutorial, I'm going to make this an int. Feel free to leave it as sbyte. But yeah, no, for the tutorial, it's actually going to be an int. So int x, int y, and we'll just say this dot x equals x and this dot y equals y. And let me just quickly check if I go over here and down here. Okay, yes. I feel like I get these backwards every once in a while. We're also going to need to be able to convert an index anywhere from 0 to 63 to a vector too. So we're going to do a public chess vector int index. We actually can use an action body. No, we can't. What am I doing? And we're going to say x equals index mod 8 and y equals index divided by 8. This is going to be a little bit slower, so I don't recommend calling that too much, but I mean, it's not terrible, a mod and a division call. And for now, that's all we need. Next, we're going to head over to our board class, and the method, so there's many different ways you can store pieces on a board. The method I'm going to go with is just a generic piece array, right? You could use bitboards. My previous script was actually a stack allocated array, so it was a span of bytes, which were my pieces, just 64 pieces. And everything actually happened on the stack as far as that board was concerned, which had its own interesting challenges, or came with its own interesting challenges. But like I said, this tutorial is going to be just simple. It's just supposed to be a foundation people can build off of. So we're going to go with a public piece array of pieces. This is going to be equal to a new piece array of 64 by default. We're also just going to make some indexers. So people can just say something like, it would be like board, and then they would get the indexer and say something like X, Y, and I want them to get the piece from that. So we're going to go public piece, and it's going to be this, and then the index. So we're going to quickly just do a normal index. It's just going to get pieces there. But then we're also going to have our X and Y. So public piece, this, and X and Y. And then this is going to be X plus Y, but Y is multiplied by nothing apparently. Oh, Jesus, by 8. All right. Oh. We also store a Boolean for whether or not it is white to move. And that is pretty much all we care about. I don't think there's any more variables we'll be adding to this. Whether or not someone can castle on the left and right side, I usually just, like, if I want to stop people from castling, I'll just state that the rook is moved. That's probably not, we'll probably be using a different method, but I mean, that's how my previous bots worked, so. Let's get our proper board constructors, so we'll just get board. But our next board constructor is actually going to be a little different. So we're going to start off with public a board, and then this is going to take in a string. This is our fen, and we'll just say this is equal to nothing for now on. All right, there's probably an awkward cut like right there. I said the F word, and I don't have any easy way of beeping that out, and I don't know how happy YouTube will be about that. So, yeah. I needed a second anyway, because the next function we're about to call isn't actually added yet. Let me check OBS, okay. So we're gonna want a method that will be able to take in a fen string. If you don't know what a fen string is, I have a link down below where you can just watch and learn what it is. Essentially, it's just a way of storing a chess position as a string. And I'm going to go ahead and just paste it in here. So what it's going to do is it's just going to be a public void load fen. It's going to take in a string, a fen string, no default, and bam, there's our logic. So ignore that for a sec. So let's step through this real quick. Our method, taking in the fen string, first checks to make sure it's not null or empty. If it is, we just return because there's nothing to do with it. And the way fen strings work is actually I can just go copy a starting fen string and set that as the default. I keep tabbing to OBS. So fen strings start with black and then they work their way to white. So they start at the top left of the board, move to the top right, and move down left to right. Did I say? No. Down left to right, down left to right, and so on. So we're going to iterate through every one of these symbols. And we have our right position set up, so our pointer is all the way in the top left. And as we iterate, we'll slowly be moving our pointer right and down. So if we look at this for loop, what we're doing, we're caching the symbol. We're saying if it's a space, so if we're right here, we're just going to completely break from this for loop because at that point we're just looking on whether or not it's white's turn to move. If it's a letter, then it's a piece, so we need to convert it from a piece. We need to convert it from a symbol to a piece, so we'll actually make a piece constructor that'll take in a char and output a piece. And if it's a slash, we need to move down a row. And we also need to make sure our x is reset too. So that's setting our right position equal to, well, we're setting x equal to 0 and y equal to our previous y position minus 1. Because like I said, we're starting at the top, so y was by default set to 7. This is also optimized for, well, optimized. It's meant for readability. So, I mean, technically you don't need continue here and you can move that up, etc. And if it's not any of those, then it's a number. So in this case, we want to increment x by that number. So to convert the char to a number, we just subtract it by a 0 char, and that magically converts it to a number. I'm pretty sure I know how it works, just definitely not enough for me to feel confident explaining it, and I can't be bothered to Google it, so tough luck. However, there's an error in here. Right position, which is that chess vector we wrote a couple minutes ago, or for me a couple minutes ago. Index doesn't exist. Essentially what this was doing before I deleted the project multiple times because I didn't like my previous 2 takes, it was just converting the x and y to an index on a board of 64 squares. So let's go implement that real quick. There's actually 2 things I want to implement, so let me go copy it from somewhere else because I can't be bothered to type it out. All right, we have 2 helper properties. So this one is our index. It takes our x and y, converts it to an index like I just said. And then this one also tells us whether or not the vector is actually within the bounds of the board. So with that complete, we can head back over here, and now it's complaining about our piece constructor. So over here, we're going to want a new constructor. This new constructor is going to, and forgive me, I'm alt-tab, so it's a little hard. This new constructor is going to take a char and convert it to a piece. Here it is. So the first thing we're doing is we're saying, okay, we're determining whether or not it's white or black. So we check if it's an uppercase piece. And then we convert the symbol to lowercase and then match that against this. Speaking's hard. We throw that through a switch statement, which says if it's P, then it's a pawn, N, knight, B, bishop, R, rook, Q, queen, K, king, and so on. Well, and so on, there's one more. And yeah, it's nothing crazy complex. Most complex thing is a switch statement that isn't really that common, or type of switch statement that isn't really that common. So let's get this spaced out properly. All right. And yeah, so we've got our default fen. I actually just want to knock out another thing real quick. When I was developing the other bot, I would find myself constantly going to chess.com, setting up custom positions, and, just adding a bunch of fen strings to my script, but I wouldn't have anywhere to store them afterwards, because just setting them as public constant strings up here, public compressed stacked strings up here, no, I wanted constant string. That was just getting constant. That was just getting fairly messy. My crude solution was just to go public static class fens. Well, I named it something else. I don't remember, but fens works. And then we can do public constant string, and then get that in here. And then this was our default string. And now over here, we can just say fens.default. And actually, I wanted to make sure I was calling this the right thing. So if I just were to pass in, if I were to just pass in fen, use expression body. Okay, that's what it's called. I was calling it an action body. And the other one's the block body, right? Block body? Block body, yeah. All right. And that's all we need for the board. All right, so I'm not the happiest with this part of the tutorial. But essentially, I have a script that just makes it easier to interface with the console. It just makes it easier to write colored things to the console. And I don't really feel like it's a good thing to have a whole section of the video dedicated to writing it. It just feels like one of those things where you can just go to GitHub and copy it. Like, it's not anything special. It's just kind of, well, I've never actually heard the definition for boilerplate, so I hope I'm using it right here. But it's just generic boilerplate code to help make other things later. So as far as I'm concerned, I'm just going to add a new class. It's called Console, and we're just going to pop all the code in here. So you can just take this from GitHub. I still added a couple comments, but, and this is not from the source project anymore. So nothing really special here. It's still just got your write line, write, read line, read key, read boolean. Well, I mean, you don't have that in normal console, but it's just got a bunch of basic things, except I added some extra parameters. Like, write now allows me to pass in a foreground and a background color. The reason why that's helpful is for the next class, which I will be explaining. And this one is our board rendering extensions. I want to be able to render the board to the screen, but I don't want that in my logic project because I want to space out my UI from my core code, my logic. So we're going to go ahead and we're going to add a new class here. We're going to call this a Board Rendering Extensions. Please say I spelled that right. Oh, look at that. I feel like that's not something I should be happy about, but, get rid of all this, just clean it up. No pesky underscore. And before we get started with writing this out, I actually just want to make sure that our dependencies are done correctly. Hey, editor again. He wanted to get the dependencies set up correctly, but he didn't check OBS before recording. All I did is I right-clicked on dependencies, I added project reference, checked off the chess engine project, and then I hit OK. And now we can start coding. And by start coding, I mean for me copying and pasting stuff. Why is that grayed out over here? Okay. So the first method we need is converting a piece to a color. So that's just going to be public static or console color, get piece color. It's going to take in a piece. The first thing we're doing is we're checking if the piece is white. If so, we're going to run it through this switch statement, which says based on the type, return a different color. In this case, pawn is magenta, knight is red, bishop green, and so on. It'll make more sense when I run the program and show you. And if it's black, then essentially just return the dark variants of all those colors. And this method is helpful because our next method which is the actual extension method, and the whole reason our class is named this way. That's a later issue. Is for our render extension method, which extends the board class. Essentially, it starts from top to bottom, left to right, as that's just how you write to the console normally. I'm not doing any funky shenanigans to do otherwise. And it's just displaying each square and changing the color of the square based off of what piece is on it. And if there's no piece on it, then we're going to use a background color so we can get our nice, like, checkered background. And it's also writing the letters of each square, the letter location of each square. So just stepping through, at the top, we write the evaluation for our board. For now, it's 0, but we're just going to write out like an evaluation function later. And then our first for loop is iterating over the y, because like I said, we want to start top to bottom, and then we want to move left to right. And then the next for loop within that is actually doing the left to right stuff. So we're going to cache the piece from our board. We're going to say if the piece is null, then we just want to get our background going. So we're going to add x plus y. We're going to run that through a modulus operation of 2, and we're going to check if that's 0. If it is 0, then we're on a dark square, so we're going to color that dark. We're going to write essentially a square to the screen, because if you have two letters, if you write two letters and you kind of get their bounding box, you'll get a square. Conveniently, the letter location of each square is 2 letters. And that'll make more sense once we get this in. So we write a square of text, and then we color it. So since this is the background, we're going to want to make the foreground text itself gray. And like I said, since this is a dark square, we're going to make the background dark gray. And then otherwise, we're going to invert the colors over here. However, if the piece is not null, then we want to write the color of the piece to the board. So in this case, we're still going to write the letter location, and this will make more sense in a moment. I'll tell you. And the foreground text that we're going to be writing is still just going to be light gray. However, we're now going to be passing in the piece color as the background. I'd love to show you, however, we need to quickly define this function real quick. So by control clicking, I am going to head over to ChessVector, and we're going to define that method. And by define that method, I mean I'm going to head over here and copy this. I'm going to paste it because I am lazy. All right, so what's going on here? Our public read-only string method, ToLeterLocation, is using the expression body to immediately return x running through a switch statement, just saying if 0, or if it's 0, return A, 1, return B, and so on, up until our default, or our catch mabob, just says question mark. And then we're adding to that y plus 1, because if we don't do that, then we'll get something like, where E2 to E4, well, if we were writing E2 to E4, this would come out as E1 to E3. And that's just, if you look at a board, that's just not right. So, this 2-letter location is just converting our vector2 into a more human-friendly format. So we're adding 1 to the y, and then we're getting a substring of that. And we're taking one piece. If you try to do that, it breaks. So just giving you a heads up. So what this is doing is these 2 dots mean we're taking, because it's in front of this number, we're taking one piece. If we were to do something like this, then it would get a substring where we skip the first element and take everything else. Or we can do this, where we skip the first element and then take one element. These are pretty cool, but we only want to take the first element. And then this is just a generic function. You don't need to actually have an instance of ChessVector. You just give it an x and a y. And yeah, now that that's finished, we can go ahead and look over at our board rendering extensions. Oh, this is supposed to be static. And yeah, no worries. So we can head over to our program, get rid of this hello world, because we are not saying hello to the world. We're playing chess. So we're going to go ahead and make a new board. This is our game board. We're going to set this to new. And then we're going to say gameboard.render. and then we're going to say console.readline. What? Does it specify? Oh. I was gonna say, I've never had that error when I typed out this exact thing. Why is it here? Didn't remove the underscore from here, which, I mean, I deleted the class that was over here, so I shouldn't see that there. Yeah, and now we can go ahead and we can run this. This is my first time build, so it's gonna take a split second. All right, so many things just happened from when I said it's gonna take a split second to now. Now that OBS is actually capturing my whole screen and not just Visual Studio, you'll see that our board has rendered out properly. We've got our pawns, we got all of our cool pieces. And if yours does not look as big and square as mine does, then we can right click on the top, go to Properties. We can check our font size, so we got options, font, layout, colors, terminal. If we go to font, I have my font size set to 64. I've got my font, or I got the font itself set to however you pronounce that, and I also have bold fonts selected. So yeah, this is what I meant by the more human readable Vector.2. So as you can see, instead of it saying something like, what is this, 0, 1, 2, 3, so instead of this saying 3, 2, this just says D3. And yeah, that really long time period in between when I built it, or when you guys saw me build it and me actually hitting play, a bunch of things happened, like the project wasn't set up right, or this wasn't, my OBS wasn't recording the right things, and I messed up a bunch of stuff. I also had an error because you guys, well, I'm pretty sure, I don't know if I said this in the beginning already, the public board, like the default, that's gotta get removed. Can't have it. I don't know why I added it. Shouldn't be there. Should be gonzos. But yeah, no. So I also have this because I showed you that if you go to chess.com and you can go over to the classroom section by hovering over this hat, going to classrooms, going new room, set up position. You can set up whatever you want. So we'll say white made this move. Yeah, white made that move. And then black made that move. And then black actually made that move afterwards too. And that. And then took. So let's say we want this awesome board position of, I don't think, a single legal move. We're going to go over here and we're just going to go ahead and paste it. So we're going to append it to our static class of fens. And then over in our program, we're going to go board.fens.demonstration. And now if we run it, bam, whatever that is. Yeah. All right. But that wraps up our board rendering. Next video, we're going to be getting legal, no, we're not. We're going to be taking in user input. So someone's going to be able to go E2 to E4 and then bam, and then it's going to move this non-existent pawn up 2 spaces. We're also going to be able to undo, so the user will be able to go undo, and it's just going to close out the program on the spot. Oh, I typed in the extra N because I was typing undo. I was like, how did demonstration just become an error? Also, just in case this comes up in the future, if you see an error, like for example, if I suddenly hit N here and I didn't realize, I hover over it and you don't see anything, that's just because I misconfigured Visual Studio, or I misconfigured OBS. That is an editing mistake. It shouldn't be there. And I'll try not to make it, but it may happen. So if I just look retarded as I'm hovering my mouse over it, that's why. That being said, the video after we get our user input is likely going to be getting legal moves. And our first bot, our rando bot, which is just going to be taking all the legal moves we can make, picking a random one, and then making it. And yeah, I hope you enjoyed this video, and I'll see you in the next one.